Good evening, everyone. I have to say that I'm really happy to be there tonight because there are a lot of people I know and I consider as friends in the audience, and there are also a lot of people I don't know, and I'm really excited about meeting you tonight. But tonight I will talk to you about scary stuff, about security, about dangerous stuff, so let's go for that. So I've called this talk NoSQL Injection, Applicative DoS, which is a lot of buzzword in the security world, but we'll go through them. But the subtitle might be easier to understand: how to find security exploit by just reading the doc. Because at the end of the day, you will see that just reading the doc is a way to find problem in some systems and a way to exploit them. I'm Vladimir de Turckheim. I'm the Node.js guy at Sqreen, which is an awesome security tool for application. Feel free to browse what we do. I'm also part of the Node.js Foundation Security Working Group, meaning if you've got questions regarding Node security, feel free to ping me. We are hiring, but that's not the topic tonight. So that's the outline for tonight. We'll start to discuss a bit SQL injection and NoSQL injections. And to be honest, I will use the term NoSQL injection and MongoDB injection identically tonight. Tonight, when I say NoSQL injection, I will be only dealing with MongoDB. And then we'll see how to exploit to obtain a DoS and how to protect, because at the end of the day, is it one of the goals of security, right? So I just have a quick poll. Who is familiar with SQL injections? Okay, maybe a half, so I will still go through that concept. And who is used to use MongoDB? Okay, so I will go through the first slide a bit quick. So we just do a quick reminder of what a SQL injection is. So here we've got a simple Express controller, and we've got a query, a SQL query that is based on user inputs, and that allows you to fetch the items in a table based on their ID, and the ID is a parameter you pass from the user input. And no surprise, if the user input is ID number 1, then the SQL query becomes select star from items where ID equals 1, and the outcome of this query is obviously the item in the table which ID is 1. And every experienced developer at least should have seen that there is a massive SQL injection in this code, and if someone, instead of just the integer 1, pass something else than the integer 1 as ID, he could pass, like, for instance, or true, and the SQL query becomes select star from items where ID equals 1 or true. And the outcome of this query is basically everything in your table, and you've got a massive data leak, and let's talk about what happened to Yahoo. And it can be even worse, because in a SQL database, every instruction can be formalized as a simple string, meaning you can run another query inside after your main query with the union keyword, meaning you can even start to fetch data from another table, namely the table users. And of course, there are details about how to make that work. But at the end of the day, you are able to inject and to go through the user data of an application. And that's really bad in theory, and that's even worse with GPD legislation now. You can face like a $20 million fine. 20 million. But the other day, someone told me SQL injection does not exist anymore. We've got ORMs, we've got complex application. We don't do that anymore. So you can ask all those guys. They've been victim of that in the past 3 years, and not on legacy code. I'm not sure Instagram has code that is older than 15 years old, and I'm really generous at this point. So yeah, SQL injection are much more of a reality right now, of a current reality, and everyone should take care of that. And I see your face in the audience. I believe this talk was about NoSQL injection, about MongoDB. Yes, but I needed to go through history to understand how we went from SQL injection to NoSQL injection, because at the end of the day, nothing happened in the NoSQL world until NoSQL happened at the end of the 21st year of the 21st century, around 2009. Yes, I'm not good with numbers in English. So, since everyone is pretty familiar, since most of you are pretty familiar with Mongo, I will just go through one of the main differences between SQL database and MongoDB is that you cannot you can, but you don't formalize your whole query as a string. You've got a method that you run in your Node.js process that will call a method on the driver, but what you pass to describe your query is basically a couple between the method you want to execute, in that case find, and what kind of object you want to find in your collection, meaning you have a soft kind of a filter to parameterize your query. We will go through examples, but in this example we see that you can use some operators in Mongo to change the filter. So let's say I want all the elements in the item collection who have a property named amount, and its value must be 0, the integer 0. And you just run the first query and you get that. But let's say you want all the elements who have a field name amount, which is strictly superior to 0. And GT, of course, means greater than. That's obvious. No, it's not. And you use $GT to say, give me everything that has a field name amount that is strictly superior than 0. And of course, there are other operators than GT, like equi for equality, NE for not equals, exists, if you just want to check that something exists. And you've got other methods than find. And as the Muppets show on this GIF, that's a terribly boring slide, so let's move forward. So let's exploit a NoSQL injection, because exploiting is fun, right? So we've got another simple express controller, but this time it's a post route, but it works with get routes with some tuning, but for the example it is like that. So we've got a piece of code that allows you to search document within a collection. This collection is named document. And you build a query based on what is asked by your user as the payload of your HTTP request. Like your HTTP request has a field name desired type, and that allows you to ask for all the elements in this collection who have a field name type, which has this value desired type. So in this example, desired type is blog, so the query becomes document.find type blog, meaning the outcome will be all the documents in this collection who have a field named blog. Is that clear? Feel free to raise your hand if you want to go through this example again. There's no shame. Sure? Okay. Now we will exploit that with one simple trick. We will, with one HTTP request, display all the documents in the collection. Because nothing prevents us from just using an object instead of a string in the HTTP payload, right? And the framework will just unserialize that as a regular object. It's just a JSON.stringify at one point. So I use the NE operator that I inject into that, and I just end up asking for all document who doesn't have a type equals to the integer 0. And since into this collection the type field is supposedly a string, it means you return everything. And that's pretty bad because that's a data leak, right? You're having massive amount of data leaving your app. And maybe we want to go to funnier thing. Is it possible with such attack to prevent an application from responding to its legitimate users? So we'll just go through. I think everyone has heard of denial of service. Denial of service is probably self-explanatory. It means that your web application will stop answering properly to its legitimate user. It's a denial of service. You don't provide service to your users anymore. The most famous kind of denial of service is the one that has been extremely used, for instance, by the anonymous people. That's the network level distributed denial of service. So it's pretty much the prehistoric man way of attacking a web app. You take a lot and a lot and a lot of computers on the network. You infect some computers to put a virus that will do that. And you just all fetch the same website at the same time. And there are so many HTTP requests that fetch this web application that the application just has its CPU grows, its usage of memory grows, and at one point every server crash and the application is actively not responding. And that can be terrible because nowadays, having a web application not responding means you don't do business anymore. I mean, let's say you are a bank, your clients cannot see their bank accounts, but let's say you are just an online shop, you don't have a business anymore. You don't have a business anymore. In JavaScript in the past year, we've talked a lot about Regexp DoS. So Regexp DoS is based on regular expressions, obviously, and it abuses the fact that JavaScript runs into a single thread. You know, in Node.js, you've got your single thread, and there are a few details about how it works, but mainly for the average developer, you've got your single thread. And meaning that if you run synchronous code, you cannot do anything else. You cannot start to treat any other HTTP request, unlike languages like PHP or Java, where you've got one new thread per HTTP request. And meaning that if you've got a regular expression that runs extremely slowly, and you nourish it with very bad input, so it has to run extremely, extremely slowly, your app is just treating this regular expression and does nothing. And you can even meet case where the CPU usage is so high that the process crashes because it doesn't have any resources to do anything anymore. It happens to someone I know like 2 weeks ago. And that's pretty much a bad thing. It's a bad thing because you could theoretically destroy one instance of a web application with one HTTP request, only one. But tonight, that's not the topic. Tonight, the topic is about how to abuse MongoDB driver to obtain such results. So, to be honest, I was reading about Regexp DoS, and I was thinking, is it possible to abuse Mongo because Mongo has a way to perform Regexp against documents? So I tried to reproduce Regexp DoS into Mongo, and I failed miserably. But I spent like hours going through the documentation of Mongo until I stepped upon the documentation of the Node.js driver from MongoDB. And then I saw something that changed everything. You see it? Yeah, that's this, the pool size. Meaning that when you use the default driver, and that's the one that is used by Mongoose, so please don't ask, is it valid with Mongoose? Yes, it is. You've got a limited number of requests your Node.js process is able to do against Mongo at the same time. Meaning that you cannot have, by default, more than 5 Mongo queries running in parallel from a single instance of Node.js. Of course, you can expand that, but that's the default parameters. So my question is, what can I do with that? Can I exhaust the pool size? Can I just make the pool size fully used 100% of the time, or at least 90% of the time, meaning that nobody could take a connection to Mongo anymore, and nobody could answer to their Mongo request anymore, so they wouldn't be able to answer to their HTTP request anymore, and you've got a denial of service. And then I went back to the doc. So MongoDB has 2 really, really cool features. One of them is named $where, and that's a Mongo operator that allows you to perform JavaScript queries on MongoDB side. So when you use where, you just write some JavaScript into a string, and Mongo will run that against every item in the collection, one by one. And you've got a method in MongoDB standard lib that is sleep, that allows you to interrupt the running of JavaScript synchronously on Mongo side for a given number of milliseconds. You see where I'm going with that? So let's take a simple Express controller. But as you can see, it's a bit different tonight than the previous ones. So first of all, we're using a GET because we will abuse query strings and not HTTP payload, but that's a detail. As you can see, we directly fetch into a database of dog, to a collection of dog, with request.query, because for my POC, we don't care about the rest of the code. And dogs are cool. That's why we're using dogs. There are 2 kinds of people on earth, murderer and people who likes dog. Right? So we don't really care about the outcome of the request. What we care is the app responding to its legitimate traffic? So we change a bit the way we perform the test here. First line is the URL we will use for each time. So in this case, we just call /dogs, meaning reg.query is an empty object meaning we query every item in this collection. Fair enough. The second line is AB. It's a tool named Apache Bench that basically allows you to do application HTTP benchmark to check the performance of your web server. And we will use it because it has a really cool feature that allows you to tell, I want you to run that number of requests in parallel until you reach that number of total requests. For instance, I use the -c, concurrency, meaning that each time AB will send 10 HTTP requests at the same time. And N, which is the total number of requests, meaning that the total number of requests to run across the whole testing session. So we've got -c that is 10, -n that is 100. It will run 10 times 10 requests against our HTTP server. All right. As a result, we will look at how long it is in average to run one request with AB. So that's AB that gives us that as the output of the benchmark. And during the AB session, at the same time that AB is running, we just start a single curl. A simple curl that will be our token for this is the legitimate traffic. So AB is the malicious traffic, the traffic that is trying to prevent the application from responding. And the curl, the last line, is how long it is for your app to answer legitimate traffic. How long are your legitimate users impacted by the attack? So canonical case, we've got AB being answered in less than 300 milliseconds. That's slow, that's not a big deal. And the curl is answered in 2 seconds. That's terrible, but there will be worse. If we call a single dog named Luzu, because Luzu is the best dog ever, that was my first dog when I was a kid. The AB test is much faster because you only fetch one document in the collection because there is only one Luzu in the world. And the token curl is pretty fast. It's less than half of a second. It's pretty faster than what it used to be. Okay, what if I performed a NoSQL injection, injecting arbitrary JavaScript that will run against the 10,000 documents of the collection and will wait for 1 millisecond each time for each document? So yeah, I put a buffer because that was freaking slow. And at the end of the day, I did not have a full day to build one slide. So what I did is I interrupted the test. So this is not even the full result. And in average, the AB test was answered in 4 seconds. And our token query was answered in 2 minutes. Because 2 minutes is the time after which I stopped running AB, meaning that the token query, the token HTTP request could not be answered after the attacks was performed. So basically, we degraded the service for a legitimate user enough to consider that we had an effective denial of service. App is not really responding anymore. And that's it for the main part. There are 2 slides anymore, so we'll go pretty quick. How do you protect yourself against that? So there will always be someone who say, I will just expand the pool size or add more servers. But I just need to run 5 times the number of servers you have to break one instance of your app. If you expand the pool size, we will just increase the attack concurrency. That's not really expensive. You will rate limit? Yes, but how much will you rate limit? If you rate limit so small, your user experience will be terrible, terrible. And people won't want to use your website because it will be slow. Is there any Jira user in the room? So what you want to do is to prevent the root of the evil. You want to prevent the NoSQL injection from happening in the first time. So what you want to do is to prevent people from injecting arbitrary literals in your app, arbitrary Mongo command. So you want to validate your input, and that's a pretty good practice. So if you're using Happy, you're a cool kid, so you know how to do. Otherwise, just ping me, I will show you. And if you're using Express, you're mainstream. And sorry, I'm mean tonight. I'm really mean tonight. I recommend you use a cool library named Celebrate that allows you to use a very cool library named Joy. Joy is the best library for pattern matching in Node.js for data validation. And Celebrate is just a library that allows you to build custom middleware around that. If there are any questions, but before the question part, please go to this QR code and give me feedback about this talk. That's the first time I give it. I really need your feedback to make it better. And I will ask questions. That's 2 minutes long. There are questions about how hard was it to understand? Did you like it? What would you recommend? I will really appreciate that. And if you do that, you can get some swag if I have some with me. Don't forget, we are hiring, we are Sqreen, and I was really happy to have this talk with you tonight. Woo! 10 points.
Thanks. My question is about MongoDB. So, is there a way to time out our queries so we can just, if it takes too long, we just stop it and that's it?
So there is a core concept in MongoDB that are cursors, and you can time out cursors. You can say this request read timeout, but there is a problem with MongoDB. It's extremely slow when you have a lot of documents into a collection. Meaning that you end up, as a matter of fact, in your business, either to have huge index that takes gigabytes on your server, either to have slow queries. So sometimes by design, you end up having slow queries in MongoDB. So you could time out each query based on how long it is supposed to do. And I see you smiling because you know that's impossible to just go through your code and say, this query should run in less than n milliseconds. This query. So you end up having a generic timeout for your whole application that is always too big. And even if you time out, I don't really care because what is interesting with this attack is just you need to fill the queue of HTTP requests. You don't need to prevent all HTTP requests, legitimate HTTP requests, to be answered by your app. You need to degrade the service enough or to make the number of replication of your app so high that you hurt the app or its users. So even if you time out, if I'm still able to slow down your app enough, you will lose business or you will pay a lot of money to scale your infrastructure.
Other questions?
I can talk about Ryanda.
No other questions?
Thank you very much. Please give me some feedback and good evening.